In the last lesson, we learned that transition metals need a Roman numeral in the name. Let's review a little bit though. Which of these is the reason for why transition metals need a Roman numeral and none of the other elements do? That's right. It's because Roman numeral or transition metals can have more than one possible charge. They're multivalent, right? So in this lesson, we're going to learn how can we write the chemical names. And the only real trick to that is figuring out, well, if I know they need a Roman numeral, what Roman numeral should it be? We know it's the charge, but if they can have more than one possible charge, it's something we're going to have to figure out as we go through it. So let's look at these two compounds. I have cobalt bromide and calcium bromide. You notice that the cobalt bromide needed the Roman numeral and the calcium bromide did not. Now before we get to why, and I think you know why, it's because cobalt's a transition metal and calcium's not, I want to point out how you would say a name with a transition metal, because it's important to be able to communicate as a chemist, right? You would simply say cobalt 2 bromide, not cobalt Roman numeral 2 bromide, not cobalt plus 2 bromide. You would just say cobalt 2 bromide. Simple enough, right? So the important thing here is that before we get to, well, how do we figure out the Roman numeral? Should it be 2 or should it be 4? That kind of thing. It's to know when to do it. So in other words, metals, and it's only the metal, it's only the front compound we need to, or ion that we need to think about. Metals with more than one possible charge, they require a Roman numeral, but ones that don't have more than one possible charge, they cannot have one. In other words, if we put one in here, we would get this incorrect. That's not how chemists do it, right? So how do we know this? Well, there's a couple of things. Of course, obviously you can look and see, well, cobalt is right there. It's in the transition metal area or in the honorary transition metal area. It's going to need a Roman numeral. So that's one test that will help you figure out, do I need one? Because if you need one, you got to include one. But the other one is this. If I said to you, hey, what's the charge of cobalt? You go down here and go, I don't know. But if I told you what's the charge of calcium, you go, oh, calcium's in the second column. It's an alkaline earth metal. It's +2. I just know it. Like, think about it this way. If I were to ask you about boron, it's +3. We just know it. If you just know it, it does not need a Roman numeral. But if I said to you, what's the charge of cadmium? I don't know. That's a sign you probably need a Roman numeral. So that's the other test that you can do to figure out whether you need one. So the hardest part about this is not necessarily figuring out the charge. It's knowing when you need it and being disciplined enough to not include it if you don't. So let's look at these two compounds. Now, between these two compounds, I want you to think to yourself, is it scandium, which by the way is right there, and aluminum, which is right there? Which one of those two do you know the charge of? That's right, aluminum is +3, so we don't need a Roman numeral for it. But scandium, it's in that transition metal area. I don't know about you, but I don't know its charge. That's a sign it's going to need a Roman numeral. So that's how you decide whether or not you need one. And it's really important to understand that if we were to put aluminum with its charge in there, if we were to put like a Roman numeral 3, we would get it wrong. That's not how chemists do it. So if you know the charge, do not include a Roman numeral. Okay, so scandium, we know we need a Roman numeral. How do we figure it out? Well, this, I want to remind you, is the charge of scandium. So we have to figure out its charge. And the way you do that is you make an ion list. Just like when we were working from the name over to the formula, we would make an ion list. We're going to do the same thing. Now the great thing is we already know the formula. So let's make our ion list. It has one scandium, agreed? And we don't know its charge. I'm going to put a question mark because that's what we're trying to figure out. How many fluorine should I put in the list? 3. I need 3 fluorines in the list. You see how the formula? There's 3 fluorines. That's what my ion counting list would look like to figure out the formula. Now fluorine, we do know the charge of. What's the charge of fluorine? It's -1. So if I were to add up the negative charges, in order to make it neutral, what would the charge of this scandium have to be? 3+. We now know that that is 3+. So how do you figure out the charge? And by the way, I'm going to do a Roman numeral 3 instead of putting a 3+ because you're right. So that's how I figured it out. But the way I do it is write an ion counting list. Now, I will tell you very often people don't know how to figure out the charge, even like a week from now. And as soon as I say, well, how many scandiums should be in your list and how many fluorines, put a question mark around the one you don't know and figure it out, all of a sudden it becomes, oh, this is so easy to figure out. It's the technique that matters. Make an ion counting list. And there we go. Scandium 3 fluoride. That's how we would say it. Let's try another one. Which of these two compounds, A or B, is going to need a Roman numeral? Only one of them is going to need a Roman numeral, and I want you to describe to me how you figured it out. Well, if you said B is the one that's going to need a Roman numeral, right there, you are correct. One way to figure out is, here's sodium and here's chromium. Which one of the two of those do you know the charge of? Definitely sodium. I know that this is +1 because it's in the alkali metal family. But this one, I don't know its charge. It's going to need a Roman numeral. But also chromium, it's a transition metal. And all of these things in the green area, in the transition metal area, are going to need a Roman numeral. Okay, let's figure it out. Now you know to figure out what that Roman numeral is. By the way, is it 2? No. It's not referring to the number of chromium atoms. So it's not 2. It's the charge. Remember, that's a charge. So how do we figure it out? The answer is make an atom counting list. Now I want you to help me on this one. In my list, I'm going to have how many chromiums? 2. There were 2 chromiums in the compound. I do not know their charges. How many oxygens go in my list? 3. What's the charge of oxygen? It's 2-. That's one we do know, right? It's in that area right there. We know that everything in this column is 2-. Now, I want you to think about this. We're trying to figure out what the charge of one single chromium is, not the total. But we need the total to figure it out. What's the total number of negatives? 6, I agree. So the total here, to be neutral, would have to be 6 plus, agreed? So what's the charge of each single chromium? It's 3. But I don't put a 3, I put a Roman numeral 3, right? So each one of these must have been 3 plus in order to get this to work out. So do you see how drawing the ion counting list is what helps us figure it out? And then we can work our way backwards from the one we know and figure out the charge of one single chromium atom, or whatever metal it is. All right, so you get the idea? Now the other thing I want to point out to you is this. Roman numerals go in names. Like here, that's where it goes. It does not go in the formula. See how the formula does not have a Roman numeral 3? Now I bring this up because a lot of times students will put a Roman numeral in a formula. They don't go in the formulas, they only go in the names. Do not put them in formulas. Okay, let's try another one. I want to know, does compound C or D need a Roman numeral in its name? If you said D, you are correct. How do we know? Well, nickel's right there, magnesium's right there. That's the transition metal. We don't know its charge. Magnesium, I know its charge. It's 2 plus because it's in the 2 plus column. So that one does not need a Roman numeral, and we'd get it wrong if we included it in there. Nickel does need a Roman numeral, so let's go figure it out. Now, I see that there's only one nickel. Does that mean that this is a 1? No, it's referring to the charge. So we've got to figure it out. How do we figure it out? We make an ion counting list. I want you to do that. Use this formula and draw out your ion counting list. And then I want you to tell me what the Roman numeral will be. Now, if you weren't sure about that, because we've got a polyatomic ion in here, help me work through it. Nickel, we don't know the charge of. How many nickels go in my list? Just 1. You see how there's only 1 there, right? If there's nothing there, it's just a 1. Nitrate is a polyatomic ion. How many nitrates are there? Well, there were 2 nitrates. There's 1, there's 2. Now, do I know the charge of nitrate? Sure, if I come down here, it's -1. All right, now the total is -2. What does the charge of nickel have to be? +2. What do I type in here? II. That's right. Nickel 2 nitrate. That's how we would say that. So we can figure it out, but the key is to draw this list. If you gotta draw this list, as soon as you do that, super easy. Let's try this one. Let's say this is compound E and compound F. Which one of those two needs a Roman numeral? Well, rubidium is right here and copper is right there. I don't know the charge of copper. It's in that green transition metal area. I do know the charge of rubidium because it's in the column where they're all +1. So if I know its charge, it does not need a Roman numeral. It would simply be rubidium, but not phosphide. That would be just phosphorus, right? So it's not that. It's phosphate. No Roman numeral. Yeah, you'd look that up on the polyatomic ion chart. But this one up here, copper, sulfate, we do need that, a Roman numeral there. So as I said, this would be copper, Roman numeral. How would it end? Let's see, sulfate. Boom, there it is, sulfate. I had to make sure it's not sulfite. All right, now let's figure out the charge. It's not a 1 because that's not referring to how many there are. We got to figure out the charge. What tool do we use? An ion counting list. How many coppers should I put in my list? 1. How many sulfates should I put in my list? See, by the way, sulfate's down here. Oop. Yeah, sulfate is SO4. How many sulfates should go on my list? Just 1. Because, you see if I put parentheses in here? It wasn't like there were 4 sulfates. That's not what's going on here, right? There's sulfate, that's sulfate, and there's only 1 of them because they didn't put any parentheses. All right, we don't know the charge of copper. Do we know the charge of sulfate? What is it? It's 2 minus, right? So therefore, if the total is 2 minus, what does the charge of copper have to be? 2 plus, and what goes right here? Roman numeral 2. Very good. All right, let's try this one. Let's say this is G and H. Which of those compounds will need a Roman numeral and which one won't? Definitely H will need a Roman numeral. Palladium is right here. Potassium's right there. I know potassium is +1. It's in the column that has a +1. I know its charge. It does not get a Roman numeral. Matter of fact, we can't. This is just potassium sulfate. Boom, no Roman numeral. But this one is definitely going to need one. All right, I want you to type in its complete name. Not only like getting the 2 parts right, but what Roman numeral would it have? And when you're doing it, you're going to do an ion counting list to figure it out. Okay, I get palladium. We'll figure out the Roman numeral here in a second. And the N is chlor, not chlorine, chloride, right? If we're going to figure out the Roman numeral, we need an ion counting list. There's only 1 palladium. How many chlorines? 1, 2, 3, 4. This one I don't know the charge of. What's the charge of chlorine? -1 because it's right there and it's in a column we know is -1. That's a total of -4. So what's the charge of palladium? +4. What do I put right here? It's not +4. What do I type here? IV. That's right, IV. So that's how we figure out the charge of our Roman numerals. All right, now the last, we got a couple things we got to do here at the end, but I want you to see if you can figure this one out. If I have a mystery metal X, so clearly it's some metal I don't know its charge of, right? But it makes this compound. I want you to use an ion counting list to figure out, well, what must be the charge of X? And then type in that charge. Well, if we're going to do an ion counting list, I only see 1 X. How many sulfites do you see? Sulfite is SO3. Do you see it right there? That's sulfite. How many do you see? There's 2, right? There we go. What's the charge of sulfite? 2 minus, I think, right? Yep. So therefore, what must be the charge of X? 4 plus, right? Because if it's going to balance the 4 negatives to be neutral, the charge of X is 4 plus. So we can always work our way backwards and figure this out. Now here's the last thing, and I do want you to get out some notes to make a note of this. There are actually 3 transition metals that do not get a Roman numeral. There are 3 exceptions. One is zinc, the second one is silver, and the third one is cadmium. The only 2 you need to know are zinc and silver, and you might wonder why not cadmium. Well, the reason is cadmium is an extremely rare element. We'll never use it in lab. It's like the 64th most common element. It's so rare that we're never going to use it. But zinc and silver, if you ever see a compound like zinc chloride, it's just zinc chloride, no Roman numeral. If you ever see silver bromide, it's just silver bromide, no Roman numeral. So those two you got to keep an eye out for, and you need to know their charges. Zinc is 2 plus. Silver is 1 plus. Now how do I remember that? Because you got to know it. The way I remember it is, I know that aluminum up here is one of these ones that I just know its charge. It's 3 plus, because it's in that column, right? And aluminum is 3 plus, zinc is 2 plus, and silver is 1 plus. See, 3, 2, 1, working down that diagonal. It's kind of a cool trend, huh? So if you ever want to know what those charges are, you go, oh, I know what aluminum is. It's 3 plus, zinc must be 2 plus, and silver must be 1 plus. But if we ever see zinc or silver, we're not going to include Roman numerals with them. They're the exceptions. By the way, if you're wondering, cadmium is 3 plus. It doesn't fit any exception, but it'll never show up. Don't worry about it. Don't worry about it. It's only silver and zinc and silver you need to know. So there you go. Now we know how to name transition metals. They need a Roman numeral if they aren't zinc and silver, and the way we figure that out is by using an ion counting list.